in chapter 1, midpoint formula is x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, and so you said that means I'm going to do 0 plus 2y and divide it by 2. And then what else would I do? Exactly. Okay, and then let's simplify that. So what is 0 plus 2y? And 2y divided by 2? Just y. All right, and then on the other side, what do I get? Can I add 2x plus 2z? No. So then I can still simplify though, right? What is 2x over 2? And 2z over 2? Z. So this should be what? Careful, are we multiplying? Nope. X plus z. Good. So x plus z. So this would be our answer using our midpoint formula. Questions on number 1? Okay. Number 2. What is number 2 requiring you to use? Pythagorean theorem. We're dealing with a right triangle. They give us the length of one leg and the hypotenuse length, and they ask us to find the length of the other leg. I would probably draw a picture since I'm very visual. Helps me see it better. One leg is 12, the hypotenuse is 13, and they're asking me to find the length of the other leg. So what would I plug into my Pythagorean theorem?
A squared plus 12 squared equals 13 squared.
All right. Because we know Pythagorean theorem is a squared plus b squared equals c squared. So I have a squared plus what? 144 equals 169. Then from there, okay, so I would have a squared equals what when I subtract 144?
A squared would equal 25.
25. And then what do you do to solve for a?
Square root.
Square root. Now be careful. What's the answer when I take the square root? Plus or minus 5. Remember that every quadratic, and it's a quadratic if the exponent is a degree of 2. Every quadratic should have 2 solutions. So in this case, when you take the square root, the rule that we've learned is it could either be plus 5 or minus 5, because when you square it, both of those give us 25. But then you go back to your picture. Can you have a negative side length in a triangle? No. So for geometry, we would say the answer is just positive 5. But if you were in Algebra 1 or Algebra 2, you would say plus or minus 5. Because depending on the situation, that variable could be a negative 5. Are you guys with me? Okay. Distance. What's our distance formula back from chapter 1? That's your quadratic formula, not distance formula. What's
Square root of the sum of the x's, the square root, like the square root of that, and then plus the sum of the y's, square root of that.
okay, close but not correct. You do have a square root. The square root's over all of it. Should be the difference in the x's. So it's x2 minus x1. And then what do you do to that quantity? You are going to add it, but there's something you have to do before you add.
Square.
You not square root, but square it. So you should have a square. Okay, the square root is the symbol that's over the whole entire thing. This keeps going, but you subtract the x's and square them, then you subtract the y's and square them. And you find out their sum. Okay, so it's the square root of the difference between the x's, the difference between the y's, those quantities squared, add them together. Going to have to know your midpoint distance formulas for the entire school year, so super important that you go back and study those if you don't remember them. Okay, so then they tell us that b is greater than a. So before we plug this in, normally it wouldn't matter whether you do 0 minus 0 or whether you do the other direction. Wouldn't matter if you did a minus b or you did the other direction, b minus a. But they want you to keep in mind that b is greater than a. So keeping that in mind, and we're trying to find distance, which is supposed to be a positive number, should we be doing a minus b or b minus a? Exactly. If b is bigger than a and we want to have a positive difference, then we should be, a positive distance, then we should be subtracting b minus a, the bigger one minus the smaller one. That's the only reason this is important right here. Okay, so then from there, we're just going to plug it in. So we have the square root of, we'll have 0 minus 0 squared plus b minus a squared. Simplify, what's 0 minus 0? 0. What's 0 squared? 0. So we end up with the square root of b minus a squared. But since all of that is squared, and all of that is under the square root, what's going to happen with the square root and the square? They just cancel out. They're opposite operations. So the square root and the square cancel, and so we're left with b minus a. And since we can't subtract those because they're not the same variable, that's our answer. The point in this bell work is that you're going to be using these same ideas with variables in section 4.8. 4.8 is going to be about coordinate proofs. We're not going to do the entire coordinate proof. We're going to set it up. But the lesson's going to be about using variables instead of numbers, because to prove something, you can't prove it true for just one set of numbers. You have to prove it true for any number. And that's why we use variables in algebra, to represent any number that it could possibly be. So what we were doing was calculating what would it be for any set of numbers when we had our variables there. Any questions right now on 1, 2, or 3 before we move on? Okay, if you are a band kid and you are watching this video, I would warn you that we have a bell work on the board. I'll take a picture of it in a little bit and send it out to you, but you need to make sure that you know how to do this bell work. Super important. It's solving quadratics, again, by factoring or using the quadratic formula like we did the other day in bell work. Okay, so raise your hand if you think you have an answer for numbers 1 or 2 on the board. Okay, I've got 2 out of 7, maybe 3 out of 7. All right. So let's see if anybody has the correct answers, and then we'll work them. So be willing to be wrong, okay? Go ahead and say your answer in case you have it wrong. It's okay. What did you guys get for number 1?
I have x equals 3.5 or negative 3
3.5 or negative 3
1/3.
and a third? Okay, anybody have a different answer? Go ahead. Negative 8 or positive 9. Anybody have a different answer? Okay, that's not what I got, either one of those, but we'll check and see. Did anybody get an answer for number 2? Go ahead. Good. 3 or negative 0.5. I'm going to put negative 1/2. Same thing. Doesn't matter. That is what I got for number 2. So let's check these. So number 1, 6x squared minus x minus 12 equals 0. You could have plugged that into the quadratic formula, but keep in mind you're not going to have a calculator. So if you're using quadratic formula, you do have to be able to do all the math without a calculator. So those numbers could get fairly large, okay? I'm going to try to encourage you to use guess and check and factor if it's factorable. So remember with guess and check, we talked about this the other day. We know that since it's a trinomial, that it should factor into 2 binomials, right? With guess and check, you start with your first term, 6x squared, and you list all the factors of 6x squared. What are all the factors?
2x and 3x.
Okay, 2x and 3x. What else?
1x and 6x.
Good, x times 6x. Are there any other things that would multiply to give us 6? Okay, so then this is where guess and check comes in. You're going to pick one of those to go in as your first terms. You may not pick correctly the first time and it may not work out. So which one do you guys want to try first?
2x.
Okay, 2x and 3x. Okay, then the next thing you do is you look at your last term, which is negative 12. And you find the factors of negative 12. What are the factors of negative 12?
Negative 4 and 3.
Negative 4 times positive 3, or negative 3 times positive 4, or negative 2 and positive 6, or negative 6 positive 2. What else? So negative 1 and positive 12, or negative 12 and positive 1. So now we have a lot of things to try, right? When you try, don't just blindly guess. Remember what you're trying to check for. You want your outer terms and your inner terms, when you multiply those and add them, to equal this term in the middle, negative 1x. So try to think about what might be some good pairings there to check out. And then just guess and try. So which one do you guys want to try first? Doesn't matter. Pick one. Okay, so let's try -4, +3. Again, it's going to make a difference where we put them, because if I put the -4 here, I'm multiplying it by the +3. If I put the -4 here, I'm multiplying it by the +2. So you're just going to guess where to put it and then check. So then you're going to do your outer. What's 2x times 3? And then you'll do your inner. What's -4 times 3? -12x. If you add those, do you get -1x? No. So it may be that we need to switch these. Let's try putting the +3 here and the -4 here and see if that works. Now let's do it again. What do we get here? -8x. What do we get here? +9x. We're close. What do we get when we add those? We get +x, but what do we want? So instead of using the +3 and the -4, what should we have done? Probably -3 and +4. So let's just change our signs here. Let's make this a +4 and make this a -3 and check. What's 2x times 4? +8x. And then we have a -9x. And does that give us -x? Okay, so guess and check is just one of those things. It looks like it might take forever, but if you think about your outer and your inner numbers a little bit before you start plugging things in, it'll go a little faster. So then you take each of those, 2x minus 3, set it equal to 0, or 3x plus 4, and set it equal to 0. And then you solve for x. So what do I do here? Add 3. So now 2x equals 3, and then divide by 2. So x should equal 1½ or 3/2, however you want to write it. Or here we're going to subtract 4. So we have 3x equals -4, and then divide by 3. So we get -4/3, or you could write that as -1 1/3. Those should be our two solutions. Does that make sense? Questions? Again, if you're struggling with factoring, you can definitely use the quadratic formula. You just have to make sure you have that memorized and that you are careful with your math and you don't make mistakes with the numbers. Okay, let's try the next one. So Marlene did have this one correct. Let's check and see if we can get it together as a class. So number 2 was 4x squared minus 10x minus 6 equals 0. Again, I'm going to do guess and check, but if you did quadratic formula, that's totally fine. We know it's going to factor into two binomials. Start with your 4x squared. What are the possible factors of 4x squared? 2x and 2x. What else? Okay, x and 4x. And now you're just going to guess which ones you want to try to start with. We'll come back to that in a second. Let's go to the -6. What are my factors for -6? -2, +3, or, okay, and what else? All right, so a little less options this time for the last term, but we still have 2 options for the first term. Keep in mind, wherever you place this, your goal is to get the outer ones and the inner ones to multiply and then add to get -10x. So think about your numbers there, and then tell me which things you want to try. 2x and 2x or x and 4x? Okay, so let's try 2x and 2x. All right, and then what do you want to try over here to plug in for our last terms? Keep in mind. Okay, so 3 and -2. Let's try it. It won't matter where we put them since we're multiplying them both by 2. So +3, -2. This is going to give me outer -4x, inner +6x. When I add those, what do I get? 2x. And we're trying to get -10x, so that didn't work. So let's try something different. I'll stay with the 2x and 2x for a little bit and see if we can get it to work. If not, we'll switch to x and 4x. So we tried this one. This didn't work. What do you want to try next? Okay, we could, but notice that it wasn't just a sign problem. It was that when we added them, we didn't get anywhere near 10. So if I switch these and do a -3 and a +2, all that's going to do is switch the signs, still not going to get me anywhere towards -10. So I would probably want to try either the 1 and -6 or the -1 and +6. Do you guys have a preference which one we try? Okay, so we'll try this one. Again, since I'm multiplying them both by 2x, it's not going to matter where I put them. And now let's do, what's our outer? 12x, and our inner? -2x. And so when we add those, what do we get? Positive 10x, but we don't want a positive, we want a negative. So then that would tell me that it's just a sign issue, so I probably need to go back and try the same numbers, but switch the signs. Does that make sense? So now that means instead of having a +6, I'm going to do -6, and then change the -1 to a +1. So now that gives me a -12x and a +2x, which does give me a -10x. So now these are my two factors. I'll set them each equal to 0. 2x plus 1 equals 0. 2x minus 6 equals 0. Subtract 1. You get 2x equals -1. Divide by 2. X equals -1/2. Here, add 6. 2x equals +6, and then divide by 2. So x equals 3. Questions? Okay, I'm going to say this again. This is probably the last time I'm going to throw this up in bell work, unless we have a little bit of downtime some other time. If you still can't solve a quadratic, either by factoring or with the quadratic formula, you need to come in and get some extra practice, or you need to go home, get online, and Google solving quadratic equations by factoring or solving quadratic equations by quadratic formula, and practice the problems you can find online with the answers that are there. And that way you can feel confident, because from here on, starting with this chapter test, every single test we have is probably going to have a quadratic problem on it. Not like this, it'll be some geometry situation where once you look at the picture, you realize, oh, I need to set these things equal, or I need to add these things. But then when you simplify, it turns out to be a quadratic equation. Okay? One thing we didn't talk about, because I set it up this way, is that don't forget the first step is always to set it equal to 0. So if it's not already equal to 0, you need to make it equal to 0. Okay? Any questions? All right. Then we're going to move on to our notes. So like I said, 4-8, we're not really going to do all of 4-8. We are just going to focus on setting up the situation. So I told you there's a lot of different kinds of proofs. We are focused on which kind of proofs in this class? 2-column. But we looked at flowchart proofs, we looked at paragraph proofs, and now we're going to talk about coordinate proofs. Coordinate proofs are where you place your object in the coordinate plane, and then you use things like slope formula, distance formula, midpoint formula, Pythagorean theorem, any kind of formula that might calculate distances so that you can prove those two triangles congruent. We are not going to do our problems completely through a coordinate proof. All I want you to be able to do is the first part of this. I want you to be able to position the figure in the coordinate plane and set up the first parts of your proof. So it's going to look more like what it did in the bell work, but we will go ahead and talk about the definition for a coordinate proof. A coordinate proof is simply a style of proof that uses coordinate geometry and algebra. And again, I told you, that's like what we did in the bell work. It uses midpoint formula, slope formula, distance formula, Pythagorean theorem, any of those formulas that might help us calculate a distance or prove something parallel. So all of those formulas. There are some strategies to where you should put your shape on the coordinate plane. You don't just want to take a coordinate plane and pick anywhere to put your square or anywhere to put your triangle. And when you do the review game on Thursday, there are some questions that are going to come back to these strategies. So it's super important. You're going to use at least one of these strategies when you decide where do I want to place my shape. So the first option would be use the origin as a vertex, keeping the figure in quadrant 1. So if we want to put a triangle in the coordinate plane, we may want to make sure that one of our vertices is at the origin and that we draw our triangle all in quadrant 1. What would be the benefit of putting it all in quadrant 1? Everything's positive, so you don't have to worry about any negative numbers, okay? So one strategy would be put it in the first quadrant and keep your vertex at the origin. That's going to make finding the distance easier because you're starting at 0. The second thing that you could do is center the figure at the origin. So maybe you have a square and you want to place your square on the coordinate plane. You could center it so that the origin is right in the middle. How would that be helpful? If I'm graphing a square and I center it at the origin, what would that do for all of my vertice points? What do you mean by opposite?
Like if your top right is 2, so you know your bottom left is -2.
Okay, so it's going to keep them all the same numbers, the same distance away from the origin, but it'll just change them from maybe positives to negatives. So if this was out, like Weston said, 2, 2, then this one's going to be at 2, -2. This one's going to be at -2, -2, and this one's going to be at -2, +2, because we're going the same distance in all of our directions. Does that make sense? Okay, so it gives us the same number to work with. All right, the third thing that you may want to do is center a side of the figure at the origin. So maybe you're graphing a square and you want to center it so that one of your sides goes up the same distance as it goes down, so that the center of that side is the origin. Again, the reason for that would be you're going up the same distance and down the same distance, so it's easier to calculate. And then the last thing that you might want to do, number 4, is use one or both axes as sides of your figure. Now in this one, be careful. If I use both axes as sides of my shape, what does that mean I have to know about my shape? If I use the y-axis and the x-axis as 2 sides of my shape, what kind of shape does it have to have or has to be in it? A right angle. So if I'm putting a triangle and I'm using the y-axis and the x-axis, I have to know for sure that it's a right triangle. Or maybe I know it's a square, or I know it's a rectangle, which have right angles. Okay? So you're going to use one or more of these strategies when you're trying to do this assignment. Okay, so we're going to start off really simple. Position a square with a side length of 6 in the coordinate plane. So we just want to make sure that we graph a square that has 6 units on every side. So what we could simply do then is, using that first strategy, place our square so that we have one point at the origin, use the x-axis and y-axis as sides of our shape because we know for sure it's a square, so we know it has a right angle, and we can keep it all in the first quadrant, so everything is positive. On your homework, what I'm going to be looking for are the vertice coordinates. So you're going to list all of the coordinates around your shape. So if it's 6 units on each side, then that means we're going to go right 6 and have a point at 6, 0. We're going to go up 6 and have a point at 0, 6. And then our final point here will be at 6, 6. So go ahead and fill that in on your notes. Make sure you have that graphed and that you've listed your coordinates. And again, the main reason we're doing this is the first step to a coordinate proof is to graph your figure on the coordinate plane. And to make your proof easier, you want to try to use these strategies. Okay, let's look at the next one. Position a right triangle with leg lengths of 2 and 4 units in the coordinate plane. So we've got a right triangle, and we want the legs to be 2 and 4. So let's graph that real quick. Where should we start with one of our vertice points? At the origin. And then should we use our x and y axis? Yes, because we know it's a right triangle. How far do you want to go up on the y-axis? Okay, so if we go up 2, then how far do we have to go on the x-axis? 4, because the legs have to be 2 and 4. Okay, so then you can just create that right triangle. And then again, you have to label the vertice points. So we know the one at the origin is what coordinates? 0, 0. What's the coordinate of the one on the y-axis? 0, 2. And on the x-axis? 4, 0. Could we have went up 4 and right 2? So you might check your answer with the neighbor and they have a point at 0, 4 and a point at 2, 0 because they chose to make the leg here 4 and the leg here 2. Doesn't matter. Any questions? All right, they're going to get a little harder. Just like in the bell work, we used variables and not numbers. So that's what they're going to be asking you to do as we go further here. Okay, so position each figure in the coordinate plane and give the coordinates of each vertex. A rectangle with a width of m and a length twice the width. Okay, so sometimes it's easier to do this without putting it on the coordinate plane and then put it on the coordinate plane. So I'm just going to draw a rectangle here, make sure we understand what we're trying to do. So if I have a rectangle, I want the width to be what?
Your width is m.
M. And I want my length to be what?
2m.
2m. So everybody with Weston. Okay, so now what we want to do is take that to the coordinate plane. Keep in mind, we don't know what m is. So everybody in this class could have a different m. You're not going to label your coordinates with numbers. You're going to be labeling your coordinates with things like m and 2m. But you want to make sure that whatever you decide to let m be, that you make sure your length is twice that. So let's say Jacob, pick a measurement for m. What do you want your width to be? 3. So then what does his length have to be? 6. But he's not going to use 3 and 6 when he labels his vertices. He's going to use m and 2m. Okay, so let's go ahead and do that on the coordinate plane. I'm going to use what Jacob said. We're going to let our width be 3 and our length be 6. So I'm going to go right 6 and up 3. Again, I'm going to use the strategy of keeping one vertex at the origin. And since I know it's a rectangle, I'm going to use the y-axis and the x-axis as sides. And then I'm just going to draw my rectangle in. But now let's label those coordinates. So what is the coordinate at the origin going to be? 0, 0. And how far did we go to the right? So what is the coordinate on the x-axis going to be? 2m, 0. Remember, we went right 2m, right? We went right 6. So this distance here, even though it's 6, we're calling it 2m, and we're calling this m. So we went right 2m, so it's 2m, comma 0. Not 6 and 3. What are we going to label the point up here on the y-axis? Exactly. We went left or right 0, and we went up m units. Again, everybody's picture may look different, but their vertex coordinates should be the same. What is the coordinate going to be for the final vertex point here? Very good. So we went right 2m and we went up m, so 2mm. Is this making sense? So you pick what you want to let that variable represent in your mind so that you can put it on your coordinate plane and you can make sure the relationships are correct. That whatever you let your width be, your length really is twice that. But then do away with the numbers and use the variables to actually name your coordinates. Let's try another one. This time we want a right triangle with legs of lengths S and T. So go to your graph. If it's a right triangle, we can use that same strategy we've been using. Keep the vertex at the origin. And since it's right, we can use our X and Y axes, right? To make a right triangle. It says you want the legs to be S and T. What does that mean about the legs?
They're different.
They're different, but it doesn't matter what they are.
One just has to be yes, one just has to
Does not matter how long they are because it doesn't give us any kind of relationship between them. It's just that since they use two different letters, you should use two different lengths. So you can go up as far as you want and you can go right as far as you want. Just make sure that they're different. Don't make them the same because that would mean they would have the same variable s or the same variable t. And then it doesn't matter which one you call s or t. Did you go up s or did you go up t? Did you go right s or did you go right t? I'm going to call up s and right t. But it won't make a difference if you had switched those. It would just switch your coordinates. So my origin is still going to be 0, 0. What is this point going to be if we went up s? 0, s. And what is this point going to be if we went right t units? T, 0. So again, it doesn't matter what you're letting your s and your t be. Just make sure they're different, but label your points with the letters, not the numbers. Any questions? All right. I think on the back, we'll do this last one, and then we're not going to do the 2 at the bottom. So position a square with side length 4p in the coordinate plane and give the coordinates of each vertex. I'm going to give you about a minute or so. Go ahead, you guys graph it, label it, see what they have up here. Again, there were a couple different strategies you could have used, so it doesn't have to be this strategy, but this one is what we've done all morning, keeping our vertex at the origin, keeping it in the first quadrant, and since it's a square, we can use the y-axis and the x-axis because we know it has a right angle. So if it's a square with side lengths of 4p, we should have went up 4p, right 4p, making our final coordinate 4p, 4p. Any questions on this first little step of putting it in the coordinate plane? Okay, so on the homework for section 4.8, it's going to be a mixture of what you did in the bell work and what we just did in the notes. So it may be asking you for these coordinates, or it may be asking you to use midpoint formula or distance formula or Pythagorean theorem. Any questions at all on 4.8? Okay, it's pretty easy. 4.9 is also pretty easy. So let's look at 4.9. 4.9 is basically going to give us a bunch of theorems that we can then use to apply to pictures to find missing sides, missing angles. So a few more theorems for us to memorize. Some more vocabulary. This is the end of our vocab, so just a reminder one more time, next class period is our vocab test. And there are, if I haven't told you already, have I told you how many words are on it? No? Okay. This is a little bit of a bigger one again. It's got 29 words. Okay? So not near as big as chapter 1, but still pretty big. So 29 words for Thursday's vocab test. Last 4 vocabulary words right here. We'll start with them. We're recalling or talking about isosceles triangles today and equilateral triangles. So starting with isosceles, remember that it has at least 2 congruent sides. And we call those congruent sides the legs. So when you have an isosceles triangle, the 2 sides that are congruent are called the legs. So in this case, this would be a leg, this would be a leg, and then they call the other side the base. So that's another one of our vocab words here. The side opposite the vertex angle is called the base. Well, what's the vertex angle? The vertex angle is the angle that is formed by the legs. So where the 2 legs meet, that vertex is your vertex angle. So if here's my leg, where those 2 legs come together makes this angle right here our vertex angle. And then the other 2 angles are going to be called the base angles. They are the 2 angles that share a common base. They share that base as a side. So angle 1 is made by the base and angle 2 is made by the base. So these 2 angles right here are base angles. Okay. Legs are congruent sides, base are the sides that are not congruent. The vertex angle is in between the legs and the other 2 angles are called base angles. Super important that you understand that vocabulary, because several of our theorems are going to use those words, base angles or vertex angle or legs. So our first theorem is isosceles triangle theorem, and you guys may already know this, but we haven't actually talked about it. If 2 sides of a triangle are congruent, so if they give you a picture and 2 sides are congruent, you automatically know it's isosceles. This theorem says if it's isosceles, then the angles opposite those sides are congruent, which are your base angles. So if it's isosceles, the base angles will be congruent. So the sides across from the congruent sides, the angles across from the congruent sides. So angle B and angle C. Again, those are the base angles that will be congruent. Converse, what does converse do? It switches it. So now it's going to say, you don't know it's isosceles. If you look at the triangle, there's no legs marked congruent, but the base angles are equal. So if the base angles are congruent, then the triangle must be isosceles, and it's the sides across from those angles that will be the congruent sides. Okay, so isosceles triangle theorem starts with you know it's isosceles. The base angles are congruent. The converse says you don't know it's isosceles, but you have congruent base angles, so it must be isosceles. The sides must be congruent. Everybody good with this? All right, this is super important. Sometimes some books call that the base angles of the base angles theorem, but we're not going to worry about that. We're going to call it isosceles triangle theorem, and then it's converse. All right, so here's our first example using that. It says the length of yx is 20 feet. If you look at the picture, yx is 20 feet. It says explain why the length of yz is the same. So we're going to have to use some things we've learned before and use what we just learned. So let's start with, if this is 140 degrees right here, and we know this angle is pointing to angle x here is 40 degrees. What could we say?
The angle right there is 40 degrees because it's a linear angle.
Very good. It's a linear pair. Good job, Marissa. So we could say this angle right here, the measure of angle YZX has to equal 40 degrees. And again, what's the name of the theorem that tells us that if two angles form a linear pair, then they must be supplementary? Marissa just said it. Linear pair theorem. So write that down because it said explain. So you're going to have to use your theorems to back up what you're saying. So we know the measure of that angle has to be 40 degrees because of that linear pair theorem, that they're going to be supplementary. And now use what we just learned. These two angles, if they're both 40 degrees, what does that mean? Okay. Well, that would be true, but that's not what we need to answer this question. What we just learned, Weston said that if these two base angles of your triangle are congruent, then what else is congruent? Good. So that means we should be able to say next that yx is congruent to yz. And what theorem told us that? Very good. By the converse of the isosceles triangle theorem. And so then what is the length? Well, I guess they already told us. The length of yx is 20 feet. So again, they're asking us, why is that true? Well, that's true because we can find that other missing angle by the linear pair theorem, and we can say that those two sides then are congruent by the converse of the isosceles triangle theorem. And if they're congruent, then they're going to be equal, so that's why it's 20 feet. Are we good? Okay, so just be able to back it up with your theorems. All right, the next one does not say explain, and actually the next couple of problems, I think, are just going to ask you to find some missing measures using that theorem. So if we look at the picture, what kind of triangle do we have based on the markings? Isosceles. And they want us to find the measure of angle F. But what did we just learn by the isosceles triangle theorem? If the two sides are congruent, what's true? The base angles are the same. So which two angles should be congruent here? E and F. Okay, so we know that these two should be the same, and we know that angle E is 22. So what can we do from things we learned before to find D and F? Very good. All three angles should add to be 180, so we can take away 22. That leaves us with 158 degrees. And if we know that D and F are the same, and together they're 158, what do we do? Just divide by 2. So 158 divided by 2 gives us what? 79 degrees. Very good. So the measure of angle F would be 79 degrees. And again, that was using the isosceles triangle theorem. If the sides are congruent, the base angles are congruent. The converse is, if the base angles are congruent, then the sides are congruent. All right, next one. What kind of triangle do we have? Isosceles. So once again, if those two sides are congruent, we should know that the two base angles are congruent. So which two are the base angles? G and J. Remember, it's the ones across from the congruent sides, or it is not the one that's in between the two congruent sides. That's your vertex angle. So what should we write down then as an equation here?
X plus 44 is equal to 3x.
Exactly. X plus 44 should equal 3x. And then it should be pretty easy to solve for x. We'll just subtract x. 44 equals 2x, and then divide by 2. And what is x? X equals 22. What did they ask us to find? Measure of angle G. So we can go back and plug that in. What's 22 plus 44? 66 degrees. Just make sure that you are answering the question, going back and finding whichever angle it asks for. Pretty easy? Okay, one theorem so far, right? Isosceles triangle theorem and its converse. Same idea, just different directions. Okay, the math shouldn't be too hard on these. It's more of applying it to the picture. The next theorem that you're going to learn is called the equilateral triangle theorem, or they call it a corollary because it follows pretty quickly from another theorem. Equilateral triangle basically says if it's equilateral, then it is also equiangular. This is only true for triangles. It doesn't work for other shapes. But if it is equilateral, it is also equiangular. If it's equilateral and we know then that it's equiangular, what do we know about every angle? They're the same, and they are specifically 60 degrees. Remember, we talked about that before, that if you take 180 and divide it by 3, you're going to get 60. So if they tell you it's equilateral, you not only know now all the angles are the same, but you know that they're all 60 degrees. The next one is just going to be basically the converse of that, but they don't call it the converse. They call it the equiangular triangle theorem. So whichever the name is what they're giving you in the picture. If it's equilateral, they're telling you all three sides are equal, and you're concluding that all the angles are equal. If it's equiangular triangle theorem, oops, my bad, sorry. If it's an equiangular triangle theorem, then it's saying, hey, your triangle is equiangular, but if it's equiangular, then it's also equilateral. So now we can mark all the sides congruent. Is everybody with me? So it just goes both directions, and the name of it is whatever they've given you. If they've given you all the sides congruent, it's equilateral triangle theorem. If they've given you all the angles congruent, it's equiangular triangle theorem. Okay, so again, some examples. We're almost done. This section's really easy. So find the value of x. What kind of triangle do we have? Equilateral. All three sides are equal. We just learned by that theorem, equilateral triangle theorem, if all the sides are equal, what else is true? All the angles are 60 degrees. Yes, all the angles are going to be congruent, and more specifically, they're all going to be 60. Okay, so if we keep that in mind, what could we write down here to solve for x? Exactly. And then we have a simple algebra problem. Subtract 32. So 2x is equal to 28. Divide by 2. And what is x equal to? 14. And this time, that's all they asked you for was x. So x is 14, and you're done. Okay, last example for today. What kind of triangle do we have? Equiangular. And be really careful when you spell that. Equa no L, angular. Okay, equiangular. So if it's equiangular, that means it is also what? Equilateral. So that means all the sides are now equal. And if all the sides are equal, what equation could we write down to solve for y? Very good. 5y minus 6 equals 4y plus 12. And once again, a pretty easy algebra equation to solve. We can simply just add 6. So 5y equals 4y plus 18. And then subtract 4y. And we end up with y is equal to what? 18. And again, that's all they asked us to find here was the value of y. Easy? Okay, hardest part I think of today is our Algebra 1 factoring and quadratic formula part. Making sure that you understand that, and maybe a little bit the bell work with the distance and midpoint with variables. Sometimes that's a little bit difficult. So if you have any questions whatsoever,